So I've got f, whoops. I've got f of x is equal to 1/6 x to the third plus x plus 1. So the first derivative would be 1/2 x squared plus 1. The second derivative would be x. Great? That's the second derivative? If that's the second derivative, then it says the next piece of the puzzle, where does the second, so concave up is positive, concave down is negative, so where is a possible point of inflection? Where the second derivative is 0 or undefined, right? So we're going to set the second derivative equal to 0. That happens when x is equal to 0. Fair enough? Now, how do I tell whether it's concave up or concave down? Check left or right. See how much fun this is? From negative infinity to 0, and from 0 to positive infinity. I'm going to go into my second derivative. I'm going to set it equal to a number less than 0. Give me a number less than 0. So the second derivative of -1 is -1. Therefore, it's going to be concave down. Remember the picture? It was concave down. The second derivative above it, let's try 1. I get 1. So therefore, it would be concave up. And at x equals 0, it's changing from concave down to concave up. So what do you call that? There is not a POI. There is a point of inflection. Yes, POI is not one of the ones they recognize because it's POI. And apparently POI is not right. Okay, flipping it over, look at number 1. Number 1, it says, determine the open intervals on which it's concave upwards or concave downwards. So try number 1. Tell me what number 1. Miss Lasagna, what's the answer to number 1? It's concave up from where to where? From negative infinity to positive infinity. That thing is concave up. Well done. Now try the second one.
So you just find the second derivative.
Well, you could find the second derivative. We're just looking at the pretty picture. Sorry for the picture, right? It's caved up, right? So we'd say it's concave up. Yeah. That's number 1. Try number 2. Number 2 is where things get interesting. All right, number 2, Mr. Smith. What do you got for me?
Concave down.
Concave down from where to where?
From negative infinity to positive.
I disagree with you. Because if you look at it carefully, and I'll admit it takes some careful looking, it's doing this, and then it's switching over, and then it's doing this. Agreed? And from wherever this point is to wherever this point is, it's concave down. But before that, it's concave up. Watch out. Just because it's going down does not make it concave down. It's which way it's curving that matters. Agreed? So from negative infinity to, what's the number? What's an estimation of the number? -2, you think?
Yeah.
Okay, I'm going to go with him, -2. I really think it's -1.5, but I'm going to go -2. Why not? -2, it's concave up. From -2 to +2, it's what, sir? Concave down. And then from 2 to infinity, it is concave up. You could. You could. I just went to look at the picture. But that's okay. I mean, you absolutely, that's what she said. We want to take a cigarette. We could. And we hopefully get the same answer.
That's what the same answer you get. Just looking at them. You get like 48.
You have 48?
Right.
No way.
Like, did you do the other side of the same thing?
Your question, really, is square the bottom over and over again.
Oh, yeah.
Okay. All right. Doing better now?
Yeah.
Good. I don't know what it is, but it should be somewhere between. I'm estimating it's somewhere between -1 and -2, or -2 and -3. Somewhere between -1 and -3 would be a better way to say that. Okay, 5. What do I got? From negative infinity to -1, what is it, Perel? Concave up from -1 to positive 1. It is concave down, and from 1 to infinity, it is concave up. Okay, you have 8 problems to do on the bottom. I want you to attempt all the way down to the one above 21, whatever that would be. That'd be 5 problems for homework. Try them.